And we continue. Geen idee meer wat ik aan het doen was hier. Oh yeah. Oh, you're working on this. Now everything is 0. That cannot be the idea, right? I broke it. Totally broke it. I was literally in the middle of something and then my doorbell rang. Or almost rang. Oh, it doesn't even compile, right? It does not even compile. Okay. That's where I was deleting stuff. Yeah, I want to pass the begin value here, the real begin value of whatever this thing is iterating over. And that should be the set index binding slot index, which represents a set index and the binding. And the type is a bit set index. And we have a begin for that, index begin. That's a POD. Oh, well, that's okay. I can construct an index from that. So we can pass that. And that is stored in utils bit set index begin. And the end is must be one past the end, right? As usual, I think so, yes. So that would be given by this. If I construct this, then the bit index. Maybe I should just change this into a static function. I don't think I'm using this as a constructor. Am I? I don't think so. So let's return the type. Yeah, no, we return it instead of assigning. To the static function get index of the set index binding slot index. Get index. And then we pass here set index end, comma, zero, I think. That's exactly one higher than the. That's kind of silly to do it this way. Yeah, anyway. Start door back. Not sure what you were saying, but the same to you. copied it. Include. You cannot pass. Oh, I hate this. I have to pass binding begin. Oh, I can do that. You can do that. This is so annoying. No, I don't know which file I was in. Oh, this file. This must be binding begin. No viable conversion from standard const bit set index POD to a shader resource index. A shader resource index? What? The second argument takes a shader resource index. I don't think so. Okay, we are in set index binding slot, which has a get sorted begin. No, it has an owner, and the owner is a shader module. Yeah, that's wrong. The owner should be well, that's a good question. That is a good question. So I want to have these things communicate, these three. And they live in, for example, declarations. Hello, Arab. I need to learn Russian because I cannot pronounce all these names. Declarations. I think declarations would be good. Yeah, something else must be using shader module. I think something else is using shader module, but what? That's scary. Uh-oh. Oh. Maybe it's not declarations. It's declaration. A single declaration. Or not. I don't know. Oh no, I don't know. Maybe it is shader. I removed something. I removed a shader resource. You see, this is such a bad compiler. The problem is with passing a type, well, passing this index begin, that type, it says, cannot be converted to a shader resource index. En dan moet ik kijken, huh? Why would it even try that? Now that depends, of course, on the type that this function takes. So if this function accepts as the second argument a shader resource index, then we have to convert this, which is an index POD, to the shader resource index. But then at least tell me which function is being called. And it doesn't say that. It doesn't say which function is being called. I mean, I know the name, but the thing like that can be overloaded. It's a member of a class. Which class? Oh, this one. Oh, this one. Oh, this one. Yeah, okay. We'll cut that out. No, I won't, but it was nonsense. Yeah, there it is, here. So it's calling on shader module the get sorted begin, and then the shader resource index is being required there. And this confuses the hell out of me, because then who is passing then? That is done by a shader resource.cpp. Oh, yeah, okay, yeah, right. Arg. Yeah, okay, well. Everything I did was wrong. Horrible. So this removes the shader resource. Comment it out, removes it, skip stuff. SetIndex.h includes setIndex.h. Brilliant. Yeah. It's the kind of thing ChatGPT would do. I think I can just undo everything, right? Everything I did today. Everything. Yeah, I'll stash it just in case, but error on new sleeve, something like this, I think. Erroneously. English is difficult. Did you know that English has like 170,000 plus different words? It's like more than Japanese. Or ridiculous. Chinese is up to 1 million, but it just depends on how you count words. I thought English would have a lot less than Dutch. But I looked it up yesterday, and English gets in the ballpark of 170,000 and Dutch 50,000. I mean, don't tell me that English has 3 times more words than Dutch. I wouldn't believe it. I don't believe it. But yeah, apparently. I see what I did wrong here. Error? No, it's not. Erroneous. I think it's okay. You have to say save if you give a message. Or create. What's the difference between save and create? Create a stash entry. Turn this big name without storing it anywhere in the ref namespace. It's intended to be used for scripts, blah blah blah. Let's not use that. So probably need save then here. Deprecated in favor of git stash push. Oh, we need push. Does push have a message? It does have a message. Okay, you have to explicitly use message. Yeah, I thought this looks unsorted. 0, 1, 2, 2. Okay, let's use one that is bigger. Yeah, 0, 0, 0, 2, 0, 1, 1, 1, 1. That's not sorted, right? But it is sorted on the name. And the name is associated with an index, and the index is listed here. So it is always sorted 0, 1, 2, 3. So buffer 0, buffer 0, buffer 1, texture 0, texture 1. That is the order. And if you take something else which is smaller, texture 0 comes before 1. Buffer 0 comes before, buffer 1 comes before texture 1, even though texture 0 is not there. So it is already sorted. Okay, no. Half a day to waste, but we are getting there. This one I'm sorting on binding number, so binding 0 comes first and then the higher bindings. These can then be anything they want, and the only thing that is not filtered yet is then the stage flags. I need to make sure that this randomly generated layout is compatible with what we have here. And that seems to be a difficult step because so let's stare at it. Let's stare at this. The stage. Everyone knows what the stage is. Pipeline has stages, and data goes from one stage to the next, until we get to the end. In this case, we have 3 stages. We begin with the first stage, and then when that is done processing, it goes to the next stage, and that processes it and goes to the last stage, in this case. Each stage can or cannot have a compiled shader module. Some stages are fixed, they don't have a code, but in this case I'm not interested in those stages, so all my stages have a shader module. They're programmable. Not even sure how many are programmable, but I'm assuming that all 3 here are. And they are ordered by some index. And then the only thing that I have here, everything else, are the declarations. So I don't even list the source code here. Of course there is a GLSL code. But the only thing that I'm really interested in is what declarations are being used in each of these shader modules that are being used by the given stage. And each declaration, for example this one, is defined by the shader resource. For example, a texture, combined image sampler, or a uniform buffer. And then which set index and binding slot it is using. This notation is also used in validation error messages. Digit dot digit, and that just means this is the set index and that's the binding within the set index. So we have a shader resource which is bound to 0.1, and we have one that's bound to 2.2, and that's all within this shader module. This shader module also binds to 0.1. Now, at the moment you compile the shaders, you can do whatever you want, but my Vulkan engine very strongly prefers not really to switch, I think, in between. That's not true. I'm switching something. You can switch in between, but the way I implemented it, the only thing that you really do is define, well, what I do is I switch to a different prepared array that defines which descriptor sets belong to which descriptor set layout, more or less. Which comes down to that this second stage can how do you call that? Shuffle the set indexes, but not the bindings. We have total control while recording the command buffer over the set indexes that are being used by each specific shader. So I don't really care that this is a 0 and this is a 2. But I do care the binding. Now, here we see that it is uniform buffer 0, which I know is a uniform buffer, the name says it, and that is bound to some set index, binding 1. And here we see that it also uses binding 1. Is that a coincidence? Hell, it's even using the same set index. Well, this is a bad example because both occur in the same shader resources. Uniform buffer 0 and texture 1 occur in both stages that we have here. And they both also use the same slot binding. I would rather have an example where that is not the case, if at all possible. Let's see, what do we have here? Oh, here's different. We have uniform buffer 0 bound to 0, 1, and the same thing here is bound to 2, 1. And then I have, that's different, right? The set changes. And this one is using texture 0 is 1, 0, and here it is 0, 0. So the binding stays the same, but the set index sometimes changes. So that is allowed. I thought it was really random, so I'm kind of confused that so far it doesn't go wrong at all. Here the binding changes. This has a stage where uniform buffer 1 is bound to 0, 1, and in a different stage it is bound to 1, 2. Yep. Okay. Now the question is that possible? I'm not sure. I would say that theoretically it is possible. But only if you can update them at the same time. So can I update a descriptor set binding with the shader resource? Can I update two different descriptor set bindings with the same shader resource? I cannot bind it to two different bindings within the same descriptor set, I think. That would be pretty ridiculous. But maybe if there are completely different descriptor sets, it's possible. I have no clue. So I'm gonna ask the gurus on Discord. Cannot make a mistake now. We type in. Can I do that? No, rather not. Question. I'm trying to understand our pipeline. Our pipeline. Nah, it's a bit fake. Trying to understand. Trying to. Yeah, understand is a good word, I guess. Understand when I can use caching for different parts that make up a pipeline. For this purpose, I wrote a program that generates random pipeline features, I guess. It currently generates the following. Let's use this one. That is the pipeline has two different stages. That use the same resource, a uniform buffer, respectively on uh, 1.2 and 0.1. That is the set index, comma binding, as usual. The set index is different. Is okay. And that is just the index of a well, I say the index of the God knows which. 1, 2, 3, 4. 1, 2, 3, 4. P descriptor sets, I guess. It's just the index into the P descriptor set vector passed to command buffer bind descriptor sets. But I'm not sure if having a different binding is at all possible. So Lunar G is, yeah, well, the company that is the most on top of Vulkan. They do a lot of work on Vulkan. They're like the Vulkan experts. So lots of companies are a member of Cronus Group, but Lunar G is like pure Vulkan, it looks like. Of course, their top experts are not on Discord, but no, Charles, for example, knows a lot. But if he understands my question, that is, you never know. Maybe I'll tell you what he types. This is one of the interesting difference. Yeah, Charles says, part of the problem I wanted to get at, so he had something in his head, right? So intelligent discussion. You have a model in your head. Even if it is a question, you have to transfer what you have in your head to what the other person, to the other person's head, basically. Then that usually works. You give a description, like you make a picture from one side, you know, you projection of it, and then you hope that the other one guesses the basic information and builds up the same model in their head, and then with their knowledge you can answer the question. So I think that feedback is necessary. So I tell something and the other guesses what I mean, and then he gives feedback. And then from the feedback, I see if he builds up the correct model in his head. If not, I have to steer it. And if that is the case, then we go and do a few back and forwards. And then we are certain that we talk about the same thing. Now in this case, we have only one iteration. I just typed something and this is his first feedback. Now Charles says, part of the problem I wanted to get at, which means that he already had something in his head after I typed my first thing. Here, question, I'm trying to understand when I can use caching for different parts that make up a pipeline. For this purpose, I wrote a program that generates random pipeline features. It currently generates the following. That two sentences already made something pop up in his head. And it seems that he stuck to that. He wanted to get at it, so ignoring what I said after that. Is that shader modules aren't compiled when you create them. Okay, that's confusing. I think they are compiled at the moment I call the compiler, but okay. They are compiled when you create a pipeline. Well, if he says so, then that must be true, but I don't understand. So in general, creating a VK shader module is just a mem copy. That seems inconsistent. I would say that if he makes a mistake here and he means to say they are compiled before you create a pipeline, and so it's just a mem copy when you create the pipeline. That sounds logical. Being able to specify the layout of vertices is how graphics pipeline libraries can do more than just mem copy. So this is over my head. Maybe he's too much of an expert. Or he and I are talking about different things. The model that he has in his head is not matching mine. Either because I just don't understand the subject at all. And I'm misunderstanding so much that he can't even comprehend that I would be thinking about that. So this is gonna need a lot of feedback, back and forward. And then VK death answers. You can bind the same resource to multiple descriptors, if that's the question. That is exactly on point. He understands, apparently, 100% what I said, what I mean, and what I need to know. Do you see the difference between these two? That's amazing. So now for me, the question is VK death rate so much more intelligent, say, or I don't know, lucky, that he immediately understands what the problem is? Or am I really something missing that is important? What Charles starts to refer at. Chase, yes. The first answer is ChatGPT. Nah. It looks like an answer, but it's nonsense. Yeah. Anyway, I really have to type something back now because I make them wait all this time. What shall I type back? I'm gonna react to VK death first, I think. Typing that seems exactly to the point of what I wanted to know. Thanks. That is. Now I need to, okay, we are done is not enough feedback. I really have to give feedback. So I'm telling him what I understand from it. So I say that is. If the binding is different, and then the update must have been to a completely different descriptor set. Between brackets, otherwise I would have updated two different bindings within the same descriptor set. With the same resource. Which seems nonsense, if at all possible. Hence, the above is indeed possible if I can update two different descriptor sets with the same resource using different bindings. And now let's react to Charles. That went completely over my head. I call the compiler from within my application. That should do the compilation to SPIR-V. And returns a shader module. Not sure what you mean, therefore, with shader models aren't compiled when you create them. I think they are. I would think that they are. And the shader module has a handle that points to the compiled shader code on the GPU. Hence I am already so confused that your last sentence that I also don't understand your last sentence. Okay, also VK death rate now says VK shader models aren't compiled when you call VK create shader model. So I use the C++ API, but I guess that makes no difference. Nevertheless, I call which returns a oh, you passed spare V code. That is already compiled. Okay, let's not say that I'm shocked. I'm shocked here it doesn't compile the shader. Let's say I call it from this function. So yeah, I pass spare V code to that already. So the compilation happens before that. No. Isn't creating the SPIR-V code from the GLSL code what is called compiling here. Okay, first feedback that I said, isn't creating the SPIR-V code from the GLSL code what is called compiling here? And Charles says no. No GPU code is generated during VK create shader model. Yeah, that happens during VK create graphics pipelines. Okay, so creating the... Oh, I get another Android. There's two compilations. This guy, I'm not reading it here. See, this guy is more to the point, I think. Death rate, somehow. I mean, this guy might know a lot, although often he says that he's out of it and hasn't worked on Vulkan for a while sometimes, so I have to add that. VK Death Ray is a moderator on this forum, so he's also very, very knowledgeable. This guy is also very knowledgeable, so all gurus. They all know much more about Vulkan than I do. So Charles says things that are true and I don't understand it, and then VK Death chimes in to make it understandable. He says there's two compilation stages with shader. One is compiling GLSL to SPIR-V, and one is compiling SPIR-V to GPU ISA. Shader C and GLSL length validator and DXC perform the first step. The Vulkan derived performs the second step. Aha! SPIR-V is an intermediate language, so it's kinda compiled but also not. The GPU does not execute SPIR-V instructions. GLSL to SPIR-V is more like transpiling. Okay. Yeah, I get it. So SPIR-V is the machine-like code that doesn't allow wrong interpretations. I think that's one of the mistakes that OpenGL made. They defined the shader code in terms of GLSL, and that then was open for different interpretations depending on the vendor. And then you got shader code that works on one GPU and not on another. So Vulkan made something else. They made SPIR-V, which is much more strict. Also text, by the way. It's just text. So yeah, you cannot execute that. It has to compile it. I now understand what they're talking about. But the language, it's not nice to code in SPIR-V yourself as a human. So what you do is you code it in GLSL, and then you use a compiler to translate it into SPIR-V. And then the SPIR-V code can be distributed and compiled specifically for the GPU that you use it on. And then there is no misunderstanding in what it means, because SPIR-V just defines at least exactly what what you want. And that doesn't matter anymore if you compile it for this GPU or you compile it for another GPU. So, and Charles says that he just picked the last stage, which is indeed the real compilation. And that compilation happens during creation of the graphics pipeline, not at the moment that you call create shader module. The shader module is just probably, I guess, just uploading the spare V code to the GPU and returning a handle to that. But you didn't compile anything yet. And then, since the compilation only happens after you call create graphics pipeline, the compilation can use also the pipeline layout. So the layout is then used during the compilation. I'm still not sure, however, what that means for me. I really don't want to talk bad about Charles, but I must say that I just love talking with intelligent people, like in this conversation, VK death rate. You know, sometimes you talk with people and you go back and forth and you seem to go nowhere, and you ask yourself, am I so stupid? And then other moments you talk to people, oh fuck, they exactly get what you mean. They just get it. That is so wonderful. Now, usually, say in my experience, I'm pretty bad at explaining things. When I was in university, I had sometimes problems. I remember a case where I had a problem and I was trying to explain it. I think I already told it on the stream, by the way. I just can't explain things to people. You know, week long discussions. And then one of those guys comes around who does get it, and they just get it. You tell them, and they get it. And then they explain it to the other, and then they get it too. So I don't know. That's clearly my fault, and that I could not explain it well. I don't know. I mean, there was someone who got me, so they get it. So yeah, is it my fault? But then on the other hand, then they were able to explain it. Or maybe those people were just, you know, kicked out of their mental image by the fact that suddenly someone else is agreeing with me and disagreeing with them. And then they rethink, and then it clicks. It's also possible, I guess. Okay. Yeah. Anyway, very early I got already done an answer from this VK death rate. He said you can bind the same resource to different descriptor sets. So I think that it is theoretically possible that texture 0 is bound to is using binding 2 in this stage, and binding 0 in this stage. If only because it is bound to different descriptors. No. Different descriptor set slots, let us call it a slot. That is, if my code supports it. Does my code support it? Pretty good question. The only thing I remember is that I used the word update. Something with update, and that will give me a lot. So let's try to filter it out by grabbing for a better descriptor set. Which is still a lot. Well, there's a good key. Descriptor set updated. It should be called as soon as we have it updated. So that definitely brings me close. Now I don't have to wade through a lot of code. It's being called here and here. Descriptor update info, and this is pipeline factory. No, I don't know. 2 places. Balance the call to descriptor set update start above. This might cause a call to signal, but that is okay, since that means that all descriptor sets, if any, have already been updated. Increment M number of running combined image sampler updaters in order to avoid receiving a signal. Oh, right. Yeah. Incrementing something here, and then we do something super difficult in terms of race conditions. I remember vaguely that I invented this trick. So this is more like a blocking call, so that we are not getting race conditions, but that I also need to unblock it. So this is not the real stuff. So the real place would then be the other one. Here. And that is from a descriptor update info object. The destructor thereof. Apparently the whole updating is done by an object, descriptor update info. Yeah, what is this base class? Update. So there's a ref count. Fill index. Yeah, maybe not, right? I think that wasn't the best place to look. Let's look at this one. Just randomly look here and there until we find the right spot. It's just a lot of code. And I cannot remember everything. There's a call to update the descriptor set. Okay, so I'm putting data in that object. And that data contains everything we need to know to update the descriptor set, apparently. This is constructed. It's a pass by value, or it's just being constructed the moment I call it. And I move it into an intrusive pointer. And then we call have new datum, which means that it is being passed to another task. Pass new descriptors that need to be updated to this task. This task, oh, this is a receiving task. So this is a task, and some other task calls this function with the data that is required by this task to do the update. Called by pipeline. So pipeline factory calls this function. And then that data is being picked up by that. So let's scrap for that. And then is the descriptor update info is true. So we get here. And then we cast it back. So now we have this descriptor update info here. Inside a combined image sample updater. Okay, so I guess it's either a combined image sample updater or a uniform buffer updater. Do I have that as well then? Another updater? It seems I'm not supporting that. It's only supported for combined image symbols. This specific thing. That is because I want to be able to change the texture on the fly. And I don't want to do that for uniform buffers. They are just fixed. Uniform buffer is a uniform buffer. No need to make them something else or something. That's my guess. That's what I remember basically. Oh, I'm kind of itching just to write my own AI. Of course, I won't be able to. If only lack of time, lack of hardware, and lack of money. But I'm having all kinds of ideas lately. Since I'm being annoyed by ChatGPT, I'm starting to think, you know, it should be done like that. And now I can't get it out of my head. I would give a leg and an arm. Well, not really, but to be young, yeah, for a leg and an arm to be young again, I would. Yeah, I think so. So be happy that you're young, my dear viewers. But I want to finish my sentence and then be able to work for, let's say, Google on AI at the forefront, and then get the chance to implement all those ideas that I have. Fuck, that would be a nice life. But I have to concentrate on this. You know, I remember in the distant past that I wanted to write something to test this, and then I think I started to write the textures test program. I never got even close to actually test this. But that was the reason that I wrote the textures test, to test this code. Okay, here's the goal. Update descriptor sets. So what we have here is the logical device. That's what we call it on. I'm passing a descriptor set. I believe the word. I'm gonna go look upwards to see what exactly it is, but I guess it's just, you know, a descriptor set. It's a frame resource capable descriptor set. Okay. Or it could be multiple descriptor sets, but that's not important. That's being hidden. Basically, it's just a descriptor set, and it is just a descriptor set because it's a combined image sampler, which is not a frame resource. Binding, okay, so we pass literally the actual descriptor set, the type, the binding. We don't have a set, of course, no set index. I mean, the descriptor set is here, and the set index is just a per shader model thing. It's not relevant here. We also have a size of the array if it is an array, and well, if it is frame resources, more info is needed. So yeah, a descriptor set and a binding number. That's basically what we have, and a type. I am not even seeing the shader resource itself. Am I complete idiot here? Because I really thought that was the case. I'm passing image infos there. Array element range I begin. Okay, what does image infos contain? It's a vector with VK descriptor image info. That is the handle to the image view in the image layout. Sampler image view image layout. That's the resource, yeah. That is the resource. Okay, so I don't even have to go into this function here. This binds that resource to that descriptor set at that binding. And I suppose nothing stops us from getting here with a different descriptor set and a different binding. And the same data resource. That is Sion Samea, yeah. We are lookalikes, it seems. I don't think those are red eyes. It's a bit small here. No red eyes. Sorry, I had no time to look up the larger image, but they're not red. Very yellowish. What is texture array? That is a texture. just a combined image sampler. Well, handles too. Yeah, I want to understand the relationship here between the shader resource, aka whatever is in the texture array, and the binding that I have here. How correlated are those? So the binding we get from the script update info. Whatever that is, let's search upwards for that. Oh, that is just that cost thing, right? Yeah. That's the cost of what we pass to here. It's a descript update info. So the descript update info contains a binding number. Yes, it does. And a pointer to the descriptor set, but that was not really important. It can be different anyway. Yeah, okay. That would be my binding then, but then I lost track of the resource then. What is that? Where does that come from? The resource sits in my texture array, which is something that we get back from the texture array range. Which we find here with a key. Factory characteristic key to texture array range. Yeah, okay. Anyway, it's related to the key, which is which we get from also on the descriptor update info. So the key in the descriptor update info is what actually refers to our texture array then. And the key is factory characteristic key containing the factory characteristic ID and the fill index. Okay. That's kind of the ID of whoever decided that this binding is necessary, aka the pipeline factory. So it's more important to look for the thing that we use to find it in. This find texture array range. So we have to see whoever is filling this thing, probably this file. Start from the top. Insert, here's an insert. This is the first entry with this factory inserted before ITER. Okay, and it comes from a texture update request. Synchronously handled in the same state here, but so here we have the image view and sampler, which is texture. That is the resource which is being passed to update image sampler array, and that's what ends up then in some database searchable by the key. So we have to look where that is being called, and that is being called from here, for example. Void void, and is also being called here. I think this is a recursive calls, or not recursive, but yeah, it's just the same thing. So in the end we end up, yeah, well, the source and the source all comes from, I guess, equals to, yeah, possibly to the names of whatever's calling this. So this is update image sampler array, but for example this one is update image sampler. So it's either with or without array. That would be those uniform buffer calls, for example this one. Frame resources count as well. And that one is in textures. I'm gonna look at textures, I think. This is just the window clause, isn't it? Strange. Combined image samplers. Update image sampler. Yeah. I post. Well, as usually it is not possible to find it back. But maybe that's a good thing. I don't see any relationship between the binding number and what the user sees in terms of the shared resource. The user has a combined image sampler object and it just calls update image sampler array. That means that it is either a combined image sampler or an array of combined image samplers. And then we pass the M tag. What is this? Yeah, okay. We have a difference between combined image samplers. That's like the shader resource thing, and then the texture represents an actual texture. So we want to show this texture on that shader resource. So this is like something that is bound to, let's say, some service that you can see, and this is just, you know, texture loaded from disk basically. And everything is related to a given pipeline factory and a characteristic range. So kind of just indicates which which characteristic is using or is in need of this texture. Where a characteristic in turn refers or stands for a shader module. For example, this characteristic stands for the fragment shader and this for the vertex shader. In the case that separate fragment shader characteristic is false, the vertex pipeline characteristic range is also the fragment shader. So in the end, it's just the fragment shader that needs it. But we need to change the index. In this case, we have two characteristics, and here we use a one characteristic. But yeah, I really wish I could find where the binding number came from. The binding number just came from the moment that we updated. What was the other one? this one. There's the binding number. So yeah, for a given shader resource, we'll run over all the shader resources used in this shader. And for the given set index, but in the end we loop over all set indexes as well. But this is about the shader module, so the GLSL code or the compiled code or whatever, including the declarations. So I already know which set index they are using and which binding they are using. And that comes from the declaration. The declaration. Okay, now if I reuse a per v, then the declarations are the same, right? So the binding number is the same. In fact, no, just the binding number. Yeah. The binding number is the same. There is a fixed relation between shader resource and binding number for a given shader module. However, a different stage means that it is definitely not the same shader module as is used in a different stage. First we have stage 0, which has a shader module. Then we have stage 1, which has also a shader module. and both of those shader models use the same shader resource for some reason, which is already unlikely, by the way, but okay, it could be a uniform buffer or something. Then they are different shader resources. Sorry, they are different shaders because they are different stages, period. No stage uses the same shader model. And therefore the binding can differ. That's simple as that. I'm finally having some insight here. Tiny little insight, right? So yeah, that's the trick. That is the trick. So let's say this texture 0 here and uses binding number 0 inside the declarations of this shader module. This shader module, that's that one. While apparently it is also used in a totally different shader module. And I mean, it's a different stage. So it's really different, totally different code, different declarations. These declarations have nothing to do with these declarations. So there is absolutely no correlation between the binding numbers, even if it is the same shader resource. So there is no problem whatsoever that this one uses binding 1 and for texture 1, and this one uses binding 2 for texture 1. No problem whatsoever. I feel so stupid. I mean, it's so simple, and I think I spent a month or something like that on finally getting that. Okay, let's try to hold on to this. Maybe I should write it down. Took me a month to get this inside. If a different, I'm typing it, I'll just show you. Blep. Typing it in Discord. If a different stage uses the same shader resource, okay, a combined image sampler, and then that must be also a different shader. Because it's nonsense that the same shader code is used for different stages. Therefore, both instances of that usage of some bah. Now, I think that's worth reading out loud again, because it took me an incredible amount of time to realize this, to formulate it. So if a different stage of a given pipeline, right? So you can add that. If two different stages of the same pipeline use the same shader resource, aka a combined image sampler, then that must, aka something dubious. It's more like, for example, or otherwise e.g. combined image sampler, then that must be also a different shader, different sphere V, aka different VK shader module. Because it is nonsense that the same shader code is used for different stages. Therefore, the binding number of those two instances of usage of that shader resource are referring to different declarations of the whole different shader code. And there is no correlation between the binding numbers used in those two shader modules. Okay. I think that was the insight that I needed. A very important part of it, at least. Yep, well, if there is more, then I hope to run into it, and I hope to get as much clear insight as this of everything. And then I'll finally understand the whole subject, and I can finish my code or go back to the code. In the meantime, it is almost 7:30, and I should cook food and eat dinner. And I don't think I have that in my house, so I should go shopping. So I'll be back later. Okay, thank you for keeping me company, the last 4 people. And I'll